Good morning, everyone. Today, we're going to discuss something fundamental in the world of electronics and computing: transistors and logic gates such as NOT, and OR. Today, we'll explore how transistors work and how they form logic gates that serve as the brains behind all modern technology. Let's get started. Transistor is a semiconductor component. It means it can be a conductor and can be an insulator. The basic function of a transistor is very simple, only as a switch. This switch has a very high speed. There are several types of transistors. The most common we find is bipolar junction transistor, or BJT. Then the second is field effect transistor, or FET. In this video, we will only discuss about BJT transistor. BJT transistor generally has three legs: base, collector, and emitter. This type of transistor is also divided into two categories: NPN and PNP. N here is negative and P is positive. So for NPN transistor, the base is positive, and for PNP, the base is negative. The use of NPN and PNP depends on the application applied. In NPN transistor, the current enters the base leg that controls the transistor, while in PNP, the control is the current coming out of the base leg. In NPN transistor, the collector leg is the leg that receives the current. Then the emitter where the current comes out, and the base is the switch. If analogized, the base is our finger when we turn on the light with the switch. Because the transistor is a switch, the transistor is used for digital use. On is 1 and off is 0, and 1 are digital binary numbers. Therefore, as mentioned earlier, transistors are very influential components in the era of information and digital. Transistors can be made very small, and the combination of several transistors can be a very sophisticated device. CPU or processor on the computer or on our phone has billions of transistors in it, and the number of transistors in the CPU will continue to increase, and this means the transistor will be smaller in size. Transistors may not be as simple as resistors, diodes, or capacitors. Transistor is a component that can be applied very simply and can also be very complex. What is gate? The building blocks used to create digital circuits are logic gates, combination of transistors that performs binary logic. There are 3 elementary logic gates and a range of other simple gates. Each gate has its own logic symbol, which allows complex functions to be represented by a logic diagram. The function of each gate can be represented by a truth table or using Boolean notation. A NOT gate accepts one input value and produces one output value. By definition, if the input value for a NOT gate is 0, the output value is 1, and if the input value is 1, the output is 0. Or a NOT gate is sometimes referred to as an inverter because it inverts the input value. AND gate, or an AND gate, accepts two input signals. If the two input values for an AND gate are both 1, the output is 1. Otherwise, the output is 0. Or gate, if the two input values are both 0, the output value is 0. Otherwise, the output is 1. NAND and NOR gates. The NAND and NOR gates are essentially the opposite of the and OR gates, respectively. They are also called universal gates. XOR gate, XOR, or exclusive OR gate. An XOR gate produces 0 if its two inputs are the same and a 1 otherwise. XNOR gate. The exclusive NOR gate, or XNOR, is logically equivalent to an XOR gate followed by an inverter. Buffer gate. The buffer gates returns the same output as same as that of input. Combinational circuits. The digital logic circuits whose outputs can be determined using the logic function of current. State input are combinational logic circuits. As soon as inputs are changed, the information about the previous inputs is lost, that is, combinational logic. Circuits have no memory. Some examples of combinational circuits are dash, adder, subtractor, decoder, encoder, multiplexer, demultiplexer. Sequential circuits. The digital logic circuits whose outputs can be determined using the logic function of current state inputs and past state inputs, and also can store information, are called as sequential logic circuits. It is a combination of memory elements and combinational gates, types of sequential circuits, flip-flops, registers, counters,